Yeah, we have seen the Java library, and we'll continue to see more of Java library support only for the developer needs for programming. Okay, so Java has got a very vast library which suits all your problems when you are developing applications. Okay, so one more library what we are going to see right now is the Util Package. Okay, and this is a very powerful package, and it is used for development of all types of Java applications. See, when you use you're going to use Java language for developing many types of applications like standalone, web-based, or mobile applications. So when you're developing these applications now, one of the most important library which is used in all types of applications is the java.util package. Very important package and extensively used package, and it's nothing but called as what? Library itself. Okay, so we're going to explore this now. We'll be seeing this util package. Yes, exploring java.util.package. It's nothing but a library. Okay, see, library means thing. Just understand that now. It is nothing but what? Set of classes. Instead of you coding, what happens? Java goes on to give you all the code. That's it. And these classes are stored in what? Packages. So that's how they are organizing. Neatly organized. Everything is very neatly organized. Understood? So java.util package is a built-in package. It's a built-in package means what? You are getting it free of cost now. That full library you are getting it free of cost, and is a very rich library provided by Sun now. It is provided by the Sun company itself. The classes present in this package are used for the development of all types of Java application like standalone, web-based, or mobile applications. Any type of an application you code, this library is very, very important. Okay, that's why you go to interviews, most of the time all the questions will be from util package. Okay, so then this package is having many utility classes. So util package means what? It is called as utility. It contains utility classes, and these classes are used for, as I told you, development of many types of application that provide. See, the package is having many utility classes. So what do these utility classes do? They provide support to data structures, data formatting, generating random numbers, time and date formatting. You have time and date now. So in one country you want to display in one style. Okay, so time and date formatting, that's called as formatting. We'll see all that. So it's giving you a very rich support for many things like this, etc. There's still a lot of support. Okay, so all the classes from this package have to be imported what? Explicitly, because only the classes from the lang package will be imported implicitly. And lastly, one most thing important is, see, to support data structures, there is something framework is given by Java, and that is called as collection framework. The collection framework is part of the java.util package. We are going to see what is collection framework only, don't worry. Yeah, so but Java collections framework is part of the util package. So that's why it becomes a very important package, java.util. Okay, so now see, in this, now today we are going to see the support of Java given to work with different data structures. So today's topic almost all is related to what? Data structures. So first you have to understand, means we'll see what is data structure, and then in other languages what you have to do to use the data structure, but in Java what you do to use the data structure. Understood? So it's a very vast topic. Data structure is a very vast topic, and a very tough concept also, but Java brings down to earth, programming down to earth, means it makes it very easy to work with any kind of a data structure. So let's see what it is first. I think you people are aware of, so we are the next heading, what we are going to see is what? Collection framework in util package. Okay, yes, so Java provides us an API. API means what? Set of classes and interfaces now. API means, full form of API means application programming interfaces, but actual meaning of it, if you see it, it is nothing but set of classes and interfaces needed to program an application. Always remember API, it is a constant word which will keep coming. API, application, full form of that is application programming interfaces. To make it simple and easy for you to understand, I would explain like this. I stands for what? Set of classes and interfaces. P stands for what? Programming. A stands for what? Application. Go in the reverse order, you'll clearly understand. Okay, so API means set of classes and interfaces needed to program an application. Set of classes and interfaces needed to program an application. So Java provides us an API means what now? Set of classes. You don't have to worry about any data structure here. Understood? If you want to work with any data structure, Java gives you a class itself. You just instantiate the class and fine, you got the data structure. You just have to use it now. So Java provides us an API to work with different data structures such as trees, lists, sets, arrays, maps, etc. Yes, now the first question what we start getting now is, what is a data structure? Understood? So what is a data structure? First you understand what is data structure, then we will see the Java support for it. Understood? That's how you have to study. There is some problem now. Okay. So what is the problem? I'll start telling you. And to solve that problem you need a data structure. Understood? So, and once you understand what a data structure is, now we are going to see the Java support for what? Java support for what? Data structure. Understood? Once you see this particular thing, you're going to see the Java support for data structure. Let's see this now. What is a data structure first of all? What is a data structure? See, a data structure is a logical way of storing and organizing data. Okay. The different examples for data structures are array, linked list, tree, stack, queue, etc. Understood? Now what is a data engine? These two go parallelly. You have to understand the difference between a data structure and a data engine. A data engine is what? What is a data engine? It's a practical implementation of the particular data structure and allows you to do what? Add, update, delete operations in the primary memory. First you understand what is data structure. A very tough subject. Okay, but see how easy Java makes it. So let's understand what is the data structure. See, this will be your application. You can develop your application using any language. It's irrespective. You will have an UI, like where the user is going to enter what? Name, phone 1, phone 2, like that he can give many values and he's going to submit. Many values he'll give. I'm just taking 3 values here. His name, phone number 1, phone number 2, he'll submit. So next what happens is, you'll be having a database also. Here also you'll be storing the data. Yes or no? So you'll be storing the data in the form of what? Tables. Obviously when you are storing the data in the database, you'll not be storing the data in a single table. You'll be going for what? Multiple tables. So here to store the data in database we use a concept called as normalization and split the data into multiple tables. Okay. So now the data is going to enter into your application from 2 places. One from the user or from the database. So finally all the data is going to come into your application and this is where you're going to process it. So you got too much of values entering now. So now see, end of the day you write logic using those values only. You are going to write logic using what? Those particular values only. So you have to hold the values now. That is what becomes important now. Okay, so you have to hold the values. Like see now, how are you going to hold the values? Now see, I am not talking about what Java language is giving the support. We are talking about the common problems what we face while developing an application. And now once you understand the common problems while developing an application, then you have to see which language gives you better support to solve that particular problem. Understood? This problem, see, you develop an application using C, C++, VB, that is irrespective now. Okay, so when you are developing an application using any language, these are common problems which you will face while developing the application. These are common problems. But which language gives the best support for that particular problem is becoming the question here. Okay, so VB. So now we'll see Java dominates all the way. Why? You start seeing the answers because Java is going to give you what? A library for it. And that library is present in what? Util package. Okay, let's see the basic support. See, supposingly if I get a single value, ID. If I am getting only one single value, what I can do? I can store it in what? One int. But if I start getting multiple values, okay, so now see, I can enter C. Now you are going to get a value either from the user or from what? Database. You are going to get now. How you are going to store? That's the question. See, first the support of language, you see built-in support of language. Java means all languages, all these languages, they give you what? Data types. That's very important now. This is the first support what they give you. So data types have been provided for you to what? Store values, nothing else. Because you want to write logic means you need the value and that will be stored in data type. Okay, and remember now we are dealing with primary memory. That is also one more most important thing now. This is primary memory and this database is secondary memory. This itself is a different subject. How you do store data in database, remove values from database, that's a different subject. Means how you do CRUD operations, that's called as. That itself is a different subject. But the same thing we want to do it in what? Primary memory now. Means you want to store value and all that. So now to store values in the primary memory, see the language support, it gives you data types. Again data types, there are three. What is that? Primitive data types. Then what you got? Derived types. Then you got user defined types. So we expect the support now. So you have to choose a language which gives you all the support. User defined data types, you don't like it, but you can see how important it is becoming now. Understood? So we'll see now. See, if I get a single value, I can store it in what? We'll see the existing support, and then we'll see what is the need for the data structure. The question is, why do you need a data structure when you got such immense support for storing values? Still, why do you end up needing the data structure is the question here. Okay, so see, you got the primitive types, like which one? Int, float you got, double you got. So depending on what value you want, okay, to store, you can choose your particular data type, and the value can come from any location, from the user or from the database. See, from the database, supposingly there is phone number, you might have ID, correct? Now you might have name. So like this you might have columns. You will retrieve the value from here also. So that will be stored into what now finally? Either in int or in double or in float or in some data type called as string. Name you will store it in string. Phone number you can store it in double. ID you can store it in int. Okay, if it comes from the user or from the database. So like this we go on to store the values. So fine, this is one support. Single value you can do like this. But supposingly there is one big table now which is having all phone numbers. That time, okay, we'll come to that one second, just a second. So this is one way of storing the data. Okay. So now primitive types. Next, why do you use user defined type? That's the next question. We'll go with user defined type now. Okay. Derived type I'll come next. So first I'll go with user defined type. See, when you're having such an immense support for storing values in using primitive types, next you have to store it using what? Sometimes you'll have the necessity to store it in user defined types also. Because say there are some data which will be getting related to one entity. Entity means what? One identity. Entity is a technical word. Leave technical word. Simple English meaning you take. Identity means what? One employee is on identity. One student is on entity or identity. So he will have his corresponding values. What are the different values the employee will have? Like as you are seeing, he might have his ID, he might have his name, he might have his phone number, he might have his address, he might have his email. So what you are going to do now? You can design on user defined type now. So all languages give you the support, yes or no? But how good that data type is, how rich that data type is, that is different. But all languages are going to give the support for this thing now. So here what you do? Int employee ID, string name. See, Java, it is so easy, and the string name, then what you do? You have double or int phone number only you can take. Int phone 1, int phone 2. Like this you can create one employee user defined type. Now what you will do? You create an object. After creating the object, what you do? Start filling the values into this. Okay, now see, why did I take this approach now is, because supposingly I want to store the details of 10 employees. Supposingly I want to store the details of 10 employees. Now what will happen now? 10 employees means each employee is having how many values? 4 values. ID, name, phone 1, phone 2, he can have email also. More values, but just take 4 values now. So he's having these many values. So now if I go on to store these values in single variable like int, I, float f, double d, now how will you manage your data? Whose value is stored in which variable you'll never understand. So examples here, int x, int y, float, I'll store now. Just see this. You want to store the data. If I don't use a user defined data type, see this problem you'll have. Int a, then what? String s, then int x, int y. So int a will store what? His ID 101, his name AA, then x will store his phone number 111, one more y will store the value something like this. So you have stored 4 values of an employee, but one more employee comes now. What will you do? Again you have to use 4 more variables. One more employee comes, again 4 more values. Finally, if you have 10 employees, what will happen now? 40 values, 40 variables. Now whose value is in which variable? How will you know? So like this we start finding it difficult. See, writing logic in applications is the easiest. Don't bother about that. Handling data in the application is the toughest. Because only if you know how to handle your data, based on that data you're going to write the logics now. So that is why we give more importance to handling data. Okay. So anyway, that is the reason we don't store the values into primitive type like this. See, I'm not telling primitive type is bad. Sometimes you'll use single variable. Sometimes you'll use user defined data. But end of the day, if you see user defined data is nothing but what? It is you are putting it's nothing but a group of primitive data only. So finally you'll design it. So instead of doing like this, what will I do now? I'll design an employee now. So all these values, what will I do now? I'll create an object, employee E1 is equal to new employee. In Java you're going to do this, and you're going to store all the values of E1 into, you know how to fill the values. E1 dot, you can put all the values. Okay. Then employee, or I'm still going to show it, don't worry. Employee E2 is equal to new employee. So now 4 values into one employee, another 4 values into E2 employee, another 4. So now E1 is containing values related to one employee, E2 is containing values related to another employee. So you can understand now how rich Java is giving you support for what? User defined data. C is also giving the same support. C++ also gives the same support. All languages are giving the same support. But which one is the easiest to use and work? Java. You're finding it out now. So all languages give the same support. In C you call it as what? Structure. But working with struct employee you say. Struct employee. But working with that struct is so difficult. In C++ we say what? Class. In Java we say what? Class. But Java's user defined data type are very powerful. They not only can store data, apart from that your user defined data in Java can implement OOPs also. That is the richness of this data type. And on top of that it is platform independent. So very rich data type you are getting now. Understood? See, I told you want to develop an application and you need data types. So you can find out now which language is giving you the most powerful data type. Understood? Primitive is also very rich. Don't underestimate Java's primitive types, because you know the capacity of int in Java, double in Java. They are also very rich. User defined data type also is very rich. And at the same time now let's come to derived types. So user defined data type is nothing but what? Collection of dissimilar, it's nothing but group of dissimilar data. It's a group of dissimilar data. So it will store now, and it's also one of the best way to store data. Understood? So E1, E2, again you can have employee 3. So in one object you'll store one employee details, and whenever you want you can work. Now how will you work? E1 dot means you can work with the details of employee 1. E2 dot means E1 dot ID, E1 dot name, E1 dot phone 1, E2 dot phone 1. Like that you can access the values and use it. Okay, so that is one more approach. Now let's come to why they have provided derived types, support for derived types. See, I want to store only the phone numbers. I want to store only phone numbers now. Single value you understood. Multiple values belonging to one entity you understood. Multiple values belonging to one entity you understood. Now sometimes you'll have all same values only. Like example, you're having lot of phone numbers. Let's say there are 100 employees and you want all the phone numbers now. So 100 phone numbers now. How will you store now? You are retrieving from database. 100 phone numbers. How will you store now? So you can't use 100 variables now, because if you store the data in 100 variables, what happens? A, B, C, D. It's very difficult to manage data now. So that's why we go for the support of what? Derived types. That is array. That is also a built-in support you got now. So all the phone numbers you can put it into what? Array. So such a rich, say, for all these things, you take any language now. Java is n times better over other languages. Derived types you take. Array type, you know, working with derived types in C is very difficult. Array is also built-in support you are getting now in Java. C also is giving what? Array support. C++ also is giving you array support. Java also is giving array support. But which array is better? You know, working with an array in C is very difficult. When you create an array, it contains junk values. So, you know, you work with arrays. Okay. So there are a lot of problems in those derived types in other languages. But Java gives you excellent support for all these three things now. So Java's data types are very rich, no doubt about it. No doubt about it, and easy to work also. and built-in. None of them you have to worry. All you got built-in support only from the language. Are you clear with this much? Yeah. When you are having such immense support now for storing values and handling data in primary memory, next the question comes is, why do you need data structure? Or what is data structure? First is, what is data structure? Then, why do you need the support for data structure? This is the question. Understood? See, now we are going to hold multiple values now, not one. Okay, and it is not related to one entity we are discussing. Okay, we are not, it's something like many phone numbers are there, many email are there, all that. Okay, you got. Okay, so all these values you want to store now. Okay, you want to store all the employee names. So only right now the built-in support what you are getting is only what? Array. The built-in support what you are getting is array. So I can create an array of what? Integer and store what? All the phone numbers. Or I can create an array of string and store all the employee names. I can do it. Or I can store create an array of double and store any value I want. I can do it. But there are some drawbacks with the array. Still some drawbacks are there. Even though it's the best implementation, even though you can see array is having a best implementation as compared to other languages, okay, there are some drawbacks which I will go on to explain you later. Okay, so we need the support for some powerful data structures here. Okay, like example, so this is like you might take, instead of an array, I can store the values in linked list also now. That's also a good structure. So we are dealing with what now? Not single data, multiple data now. That is what you have to understand. We are dealing with not single data, multiple data, but all the data is of similar type. It's not dissimilar. Okay, we are dealing with similar type of data now. So when you are having similar data, you understanding what similar data now? All phone numbers, all employee names, all phone numbers means what? All are similar data type now. All names means what? They are all string only now. All email IDs means what? They are all string only now. So like that you are having multiple data of same type now. So we can't depend only on one derived type now. You got only one support here. Are you following now? You understanding the support of Java? Yes, you can list now. See here, I just now told you primitive types. Java is giving how many? 8. Which are they? Built-in. Int, starting from byte, short, int, long, float, double, boolean, char. See, this is first support what the language gives you. So first support. Second support, derived types. It gives you as what? Arrays, but only one support, remember. You got arrays. Make it a small a, arrays. Third support, user-defined type. User-defined data type. It is very powerful. Java is very powerful in this. Explained only about class. You got what? Subclass, abstract class, and interface. You got this much of support, but still we need the support for some structures here. So why do you need? That is what we are discussing. See, sometimes you might want to store the values in linked list. Sometimes you might want to store the value in stack. Sometimes you might want to store the values in queue. But what are all these? These are only called as data structures. And these data structures are invented by great scientists. Language has got nothing to do with them. Language is completely independent. Data structure is completely independent. Okay. But when you are developing an application, when you want to hold values in primary memory, just understand that. You want to hold the values in primary memory now. Okay. That time you need the support for these powerful structures now. And one structure has one behavior. Like example, stack is there. What goes in first will come out last. First in, last out. Understood? Queue is there. What goes in first will come out first only. So that is one data structure. Array is there. You know array. You are comfortable with that. You got something called as linked list. And you got something called as tree. You got something called as hashing technique. So many structures are there. Now language has got nothing to do with data structures. That is only independent, this is only independent. But you have to choose one of the data structure to store values in your application now. Now to store values, you choose now. Okay, and depending on scenario, you have to decide. Don't think that stack is a good one or bad one. You can't decide like that. If it is bad one, they wouldn't have invented only. Understood? So every structure has some advantages, has some disadvantages. They have some advantage, has some disadvantage. Both you should know. And in your situation, you find which one is giving you best support. That one you have to use now. Understood? So that is what is the subject about now. I'm going to store values now. You have got plenty of data structures. Okay. So but which structure is the best? Now in this scenario, I want to store 100 phone numbers. Is stack structure good? Queue structure good? Array structure good? Queue structure good? Stack, array, queue, then you got linked list, tree structure good. Which one is good? That is very important. And one structure has one on behavior. Okay. And one on performance. So that is what you have to study. Okay. So here see, studying data structure is one side. Next, after studying it, next what you have to do? You have to study now. How does array behave? How does linked list behave? So you are understanding now. So data structure is nothing but what? A logical way of storing or organizing data in primary memory. That's it. A data structure is nothing but a logical way of storing or organizing data in primary memory now. So you study it. After studying, next what you do? You have to implement it. Means prepare a data engine. So data engine is what now? A practical implementation of the data structure. You have to implement it. After implementing, what you have to do? Then you have to use it. You understanding the problems now? Developing application is secondary, but whenever you are developing any application, these many things you have to do. Understood? These many things you have to do now. Understood? So means you have to study the data structure. Okay, studying once you will do. That's not a problem, because you are a software engineer. Once, twice, thrice, somehow you'll study it and finally you'll understand the data structure fine. But every time you go on to do a project, what you have to do? Implement it, implement it. Now implementing means what? You have to prepare the structure and see to that you can add an element into it, remove an element into it, update an element. Same thing now. We are learning how to do CRUD operations in primary memory. Inserting a record, updating it, deleting or reading. You know how to do, if you know database, you will know how to do CRUD operations in secondary memory. Now we are learning how to do CRUD operations in primary memory now. So data engine will have the full implementation of a data structure, and then you have to, it will give you the full support. So in when you are developing applications, supposingly I will take one example C, you will decide. Now what you have to do? You will come across a situation, you want to store multiple values. So you have to analyze now, which is the best. Suddenly you analyze, okay, linked list is the best structure. So you have to go and study it. After that, what you have to do? Prepare the data engine. Then you have to store it. That becomes the headache. So you are losing time there. Understood? So due to that, what happens? Yeah, this is a common problem which you keep facing when you are developing an application now. Java goes on to give you terrific libraries now. Excellent libraries. It says, you want to work a linked list, means you want to work with the linked list data structure, do not bother. We have got a class already which is implementing that linked list data structure. You want to store values in tree structure? Yes, we have got a class. You want to store values in hashing technique, using hashing technique? We have got a class. Just what you have to do? Create an object. Linked list LL is equal to new linked list. Finished. Your data structure is ready, data engine is ready. All you have to do is what now? Fill values. Can you imagine what support you are getting from Java now? What a huge, terrific requirement, and Java is bringing programming down to earth now. You don't have to worry about what now? Implementing the data engine. But you should have a rough idea about what that data structure is, how it behaves. Understood? A rough idea you should have. And all that implementation, what is happening now? Java is implementing it for you. And just directly you have to bring the code into existence. Bringing code into existence in Java is nothing but what? Creating object. Once you create the object, their code comes into existence and you can start using it. That brilliant it is. Okay, so that is what we are going to explore now. We are understanding what is the data structure now, what is the need for it. Okay, see now, in data structure, now supposingly, I can store all the phone numbers, yes. If I store it in stack, now see, we have to decide. I was talking about which structure to use. Supposingly, I use the stack structure. If all the phone numbers are stored in stack, supposingly I want a phone number which is in the third place or fourth place. 100 phone numbers I have put. I want the phone number which is in the third or fourth place now. Beginning. Now I have to remove which one? 95 elements out, then I will get what? Required record. So time. Understood? So some will bring down the performance. Means I'm not saying stack is bad. In some scenarios stack will be good. In our scenario, stack is not a suitable one. Understood? Queue is there. What goes in first will come out only first. So what you enter in the last phone number, what you put in the queue now, that will come out what now? Last only. So like this problems will start off. So even like this, one structure has one on behavior. We'll be seeing it in depth. Okay. And you have to choose it, then you have to implement it and use it. But in Java what happens? You only have to choose and use. No implementation. Just choose, use. You have got the implementation for every structure. Are you clear this now? So that is what we are going to study now. The most easiest thing now what Java is doing. Okay. So initially we'll start using all these structures. Yeah, getting the idea now? What is the data structure? So I'll be teaching you this. So apart from this, Java goes on to give you what? To store values. Support, it gives you, see, for storing values, Java support is, it is giving you data types, plus it gives you collection framework. Collection framework it is called. It is called as collection framework. I'll tell you why. Some technical term it is, leave it. But collection framework is nothing but what? It is the support given for collections. Collection framework is the support given for what? Collections. But first of all, again, what is collection? Collection is group of similar data. Collection is group of similar data. So if you want to work with collections, there is something called as a collection framework. And in this collection framework, you got many classes which I was telling you. Linked list. These are all classes now. Tree set, hash set. Plenty are there. You'll see it. You got a class called a stack. And all these classes, still more are there. All these classes are present in what? Util package. Java.util package. All these classes are present in Java.util package. This itself is called as library. So understand the point now. You have got the support for everything in Java. You just have to use it. So understand the meaning of the word library, library, library. Understood? Clear? Okay. So I'll just start showing you. Are you getting the support now? One is data types, and the second support, what brilliant support what you're going to get is collections framework. In collections framework there are many classes. I have not listed all, just I have listed 4-5 here. Many are there. Okay. And they are present in which package? If it is a class, they have to organize it now. Neatly organized. Where they are organized? Java.util package. And it's nothing but a library. And definitely this support is needed for any type of an application, you agree now? It's mobile application also you need. Web-based application also you need. Standalone application also you need. Java is giving support. That's why it's a very important package. Clear? Okay. See, even people with 4 or 5 years of experience, when they go for interview, definitely they'll be facing questions on collections. So that much important it is. So practice hard, code hard. This is the main important subject. And if you understand what are collections properly, the next subject becomes very easy. Which one? Hibernate and all that. Hibernate, collections, they are very closely related. Do not neglect. That one thing I can tell. So we are going to see what is the support given by Java to support collections now. Understood? So first basically you understand collections is group of similar data, and Java is giving you a collection framework to support or work with collections. Understood? So just when you see 2-3 examples, you start understanding everything now. Okay, see this now. Java provides us an API to work with different data structures. This is the first point what I told you. Fine. What is a data structure? A data structure is a logical way of storing and organizing data. The different examples for data structures are array, linked list, tree, stack, queue, etc. Many are there. A data engine is a practical implementation of a particular data structure and allows us to add, update, delete or select operations in a data structure. Okay. Yes, this is one diagram now. What you have to understand. See diagram 1, collection framework to support collections. That's the heading. You just tell scroll. That will not be visible now, but that's the diagram. See, this is the excellent support. What you get from Java. there's one super interface. This itself is the framework. Okay, why it's called as framework I'll be explaining, don't worry about that. Okay, but it's end of the day, you are having what here? You are going to learn what? Classes and interfaces, some methods you'll learn. Understood? Some classes are there, some interfaces are there, some methods you're going to learn. Okay, see, collection is there, one interface. You can see this. Interface, set is an interface, list is an interface, queue is an interface. Okay, the straight line indicates extents. The dotted line indicates implementation. So the dotted line is nothing but means linked list is a class now, and it is implementing what? Queue interface, list interface. Priority queue is there. It is implementing what? Queue interface. Like that it goes. See from the beginning, collection is on interface. Understood? Set, list, queue are all what? Sub interfaces. They are all what? Sub interfaces. Okay. See, this is the first time you are coming across interfaces, and you start understanding now how interfaces are used in programming. Till now we have used only what? Maximum. Classes only we have used. So this is the first time you are coming across on the data type called as interface. So these are the three interfaces. They are sub interfaces. Next. Again, sorted set is a sub interface of what? Set. Navigable set is a sub interface of what? Sorted set. So all the blue color what you are seeing, they are all interfaces. Even collection is also an interface, but this blue color is interface. This purple color what you are going to see now is called our what? Classes. That's how. But don't go on color. You depend on what? That is just for differencing we have done it. You have to understand like this by looking at what? The arrow marks. Dotted line indicates implementation. This indicates extents. That is how you have to understand the relation between classes now. So whenever you are going to work with some classes now, you should know the relation between the classes like this. Clear? So now this itself is called as the framework now. Okay, this is one framework. Now why did Java do this framework is because see, to work with one structure, end of the day with all the structures, what are you going to do? Add a record, update a record, delete a record, or read a record. Correct operations you are going to do. Agreed. You are going to do that. But for one structure, if they give you one different method name, how difficult it is. So that is why what they did, they came with some interface. See, they know what are the common things required for all the data structures. So all the common things required for all the data structures, what did they do? Now I'm explaining what is collection framework. Okay, all the common things required for all the structures, what did they do? They kept it in the interface called as collection. Common methods. Now why do you use an interface? Interfaces are used for decoupling, declaration and implementation. Yes or no? Interfaces are used for decoupling, declaration and implementation. So there will be no implementation in interface now. It is decoupled. That is one point. Second point, while teaching interface, I taught you one more point. Interfaces are used to set standards. Understood? So interfaces are used to set standards. Okay. So now see, all the methods will have only one common method now to insert a record or update a record, delete a record, something like that. So you'll be seeing it now. So like this are all the common methods required. They have been kept in the collection interface. So you have got a standard approach here. Beautiful approach. Even though it's a library, you will not get confused. Brilliantly organized it is. So all the common methods are kept here. Some extra methods will come now. Okay. Those extra methods are kept in what? These interfaces, sub interfaces. Sub interfaces. And these are classes implementing them. Which class? List is a class which is implementing. Array list is a class which is implementing list. Vector is a class which is implementing them. See, these are all classes. Priority queue, linked list, they are implementing queue. Array list, vector are implementing list. Linked asset, set is implementing set. Tree set is implementing navigable set. Like this, things are designed. Okay. So means some extra methods will be added in the next interface. Some more extra methods will be added in the next interface. Common methods for all structures, they have been kept in collection interface. Understood? Neatly organized, and the benefit you start understanding. So this itself is called as collection framework. Collection framework is what? A standard way to work with any structure. Now I'll just explain you what it means. See, supposingly you want to work with linked list. You will create an object. Means you can write your own class. You can write your own class. And in that class you can have one method, M1. Now I'll also write one class for array list. Means I want to store it in tree. I'll have my own class. I'll have one more method. Means if you have different classes and different method names, how difficult it is. Like you have to remember the class name also, you have to remember the method name also. But now what will happen? One standard method now. Understood? And you can work with any structure. That is how they are organizing it. Even though they give you a library, they organize it so neatly, cleanly, clearly. Understood? So this is one of the diagram. So remember this. We're going to work with this extensively. Okay. And you'll start understanding how the methods start coming into the library now. So this is one diagram. Other diagram is there, one more. This is second diagram. What you're going to see. Okay, here what happens. This is the second diagram. This is going to deal with key value pairs. There's something called, you can store in the primary memory now. You can store the data using what? Key value pair also. Understood? To support that also, Java is giving you something called as map. Here what happens? Map is an interface. All the common methods are kept here. Extra methods in sorted map. One more is there, navigable map. So tree map is implementing navigable map. Okay. Hash map is implementing what? Map. A linked hash map is extending hash map. So this is a class and it's extending it. Hash table is extending map interface. So this is how they have done. These two diagrams are very important. Okay, remember this. Okay, then next, here I have written dot 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 implements, straight line indicates, extends. Fine. Okay. So I got a brief idea now about what is collection. Okay, so we need the support now. So Java is giving you what? Built-in support now. So just see now. I want to store the data in a linked list now. All you'll do is class demo public static void main. Okay, you can write a linked list is equal to new linked list. Finished. The linked list data engine is ready. An object gets created now. You want to add values now? Add. So what is the method you'll call now? List. There is a method called as add. That's it. List dot add of C. C is on, assume that it's on string value. I'm adding one string value called as C. But it's here I'm hard coding the values. But these values will come dynamically for you later. Understood? Either from the database or from the user interface. I was telling you now the name of all the employees. They'll be coming dynamically. List dot add C. List dot add A. List dot add. Fine. So first what happens? Okay. So as soon as I say this, one object gets created. It's a class. So obviously it's a class implementing what now? List interface. So name is so clear, crisp. Linked list means it's a class implementing list. Hash set, it's a class implementing set. Tree set, it's a class implementing set. They'll not confuse. See how powerful names they give. Neat names. Okay. So on linked list object gets created here. In fact, there will be no values inside it. And there are some methods. Remember the point. Never forget this. In Java, every class encapsulates one or the other information. Now class linked list encapsulates linked list data structure. Done? So it is encapsulating linked list data structure. So it is ready. It is a data engine. There are methods. I'll show you. Okay. So add is one of the method. So initially when you created the linked list, okay, you can print. Actually, there will be no values. I'll show you how to work. Okay, and it will be empty. Now as I add C, what happens? It's a encapsulating double linked list. So the list starts in this object. The values will start getting added now. So one of the value which is first added is C. C pre next. Our value is C. Focus on that. Now I'll add the next element A. Now what happens? Again you are calling the add method. You are sending an argument of type what? Actually it will take an argument of type object. Okay, leave it. So what happens? As soon as you call add, again it will add one more value. Which is the value? A. So pre next, you know, double linked list it is. So what is the next value? Pre next A will be added. Finished. Again I'll add one more value E. What happens? Double linked list. It starts growing now. Dynamically as you go on adding values, it is growing. You don't have to worry now. Okay, the value has been added into what? sorry, E, pre, next. What more support do you need now? We discussed and you are seeing the support now. Understood? So fine. Now, this is how the values get added into linked list. And fine, if I want to remove, list dot remove, I don't want an element. I'll say A. Which element you don't want? Specify. What happens? This data will be deleted. So we are learning how to do what? Correct operations in primary memory, no? More than that, what you are doing? Understood? Base has its own style of storing values. Okay, that is secondary memory. But here, to work in primary memory, we are using data structures to store values and handle values. We are using data structure. One of the data structure what I am using now is linked list. So fine, it is deleted, and once it is deleted, the value will be gone. Okay, I am just calling remove method. Simple now. See now, that's what we call it as standard. Now this is linked list. Just you change everything. I'll just change it to one more class is there called as array list. Array list. So this is a class which encapsulates array structure. You know array data structure now? You got built-in support for which one? There is a huge difference between primitive array and array list. We are going to see the differences later. Okay, but array also is giving support for what? Array data structure. This array, which one? Your normal array. Array list also is giving you support for data structure. Fine. Okay, just if I change one thing, array list is equal to new array list. See, for array list class also, these are the same methods. You don't have to remember different method. Understood now why they came with those hierarchy of classes? Because if they had not done that hierarchy, for in one class will have what? One different method. It will be very difficult for us to remember. See how they give the library. Understood? So now what happens? Yes, instead of this, an object of what is created now? Array. So here also same add method is there, but this encapsulates what? Array list encapsulates array data structure. Brilliant. Understood? So what happens? You are adding now. First is what? First there will be no value. Next you will add C. Fine. Next you are adding A. Fine. The array starts growing now. That's the brilliance of array list. Your array is what? Fixed in length. It cannot grow. And you never know how many elements are going to come into your application now. So that is why we can't trust what? Array. More elements you add in an array, what happens? Array index out of bound exception. It cannot grow. It cannot shrink. See, array is a good data structure. And there are two types of array. Fixed array, expandable array. Okay. But your array, primitive array is a fixed array. We don't want that. So that's why we go with what? Array list, which can grow and shrink. Both it can do. So you see the C, A, it is growing now. E, again it grows. So you know it works on index now. There it is working on nodes. Here it works on index. 0, 1, 2. This is how the values are stored. You say remove. It removes A. And what happens? After removing, this will shrink. Understood? Anyway, that behavior we'll see later. But you are able to store data now. Tell how brilliant it is. What more support do you need while developing an application? So when you start developing an application, we look into the various support given to us by the language. One is the language support. Language support of Java is excellent. Okay, apart from that, it is giving you what? Library support like this. You know what is the language support now? What is the language support? Control statements. Then which one? Data types. Control, the 9 things what you saw. Okay, literals, data types, control statements, and operators. That is the language support. Apart from the language support for writing applications, you are getting what now? Library support. So you have to pick a language now. So it is the most easiest. Understood? Only patience, because see in other languages what happens? You have to do everything from scratch. Okay, to learn in Java it takes extra time, but once you finish learning in Java, okay, you are done. Writing logics becomes easier. But in other languages what happens? Your learning will never end. You'll go on learning, and you have to implement at the same time. Concepts also you have to study, implementation also you have to do. But in Java we only study the concept. We don't do the implementation, because implementation is already given to you by libraries. Why? Because there are people, means the common problems what keep recurring in your applications, Java will identify. See what Java exactly does is, they do nothing. Okay, After inventing the completion of the invention of language, no, when you're developing an application, they'll keep seeing the recurring problems which keep on arising. What are the common problems which keep coming again and again and again for the development of any application? It can be any domain, banking domain, insurance domain, or whatever domain. So those common problems they'll identify and they'll build a library for it. Understood? Library is nothing but what? Group of classes. Once it is given, developers need not have to code anything now. They just go on to use the library. That is the support what you get in the language. So as you go on developing applications, you'll understand this. You're still yet to enter that stage. Okay, once you start developing applications, you'll come across common problems. So for every problem now, what is Java going to do? Give a solution in the form of library. Remember this. This is how it is going to be the course now. Every problem you face, Java gives you a support now, library support. Understood? Problems, Java gives you a library. Understood? And the library is nothing but what? Classes. And where are these classes going to be stored now? Packages. Neatly organized. Understood? So this is just to refresh you how Java gives you the support for everything. Everything and everything in programming. Okay. Fine. So I'll code and show you now. Not only this, you can use what? Tree set. Same methods almost all. Which structure you want to work? Tell now. Tree set. TS is equal to new tree set. Same methods. What happens? Now data is getting stored in what? Tree structure. C, A, E. I'll show you. Means neatly you have to organize it in alphabetical order and all that. Some order is there. I'll be explaining that. But it starts showing in tree structure. And you know you have studied C language. Many times you quit C when the subject of data structure starts. Reason is what? You have to study the structure, you have to implement the structure, and then you have to use it. So we fail to implement there. Reason is pointers, concept, all will come. Here nothing is there. So neatly you are handling the data. Okay. So it's just a matter of time. Within 4 or 5 days you can work with any structure in Java. That brilliant it is. So I just code and show you now practically all this, and you start understanding. So how to code you see now. So what I'll do, since we are going with the new package now, yes, I'll continue coding in my folder, Eclipse examples. Okay, August 2013, Ravi Kumar, Java examples, core Java. You're still in core Java? Yes. So here I'll create a new folder called as Util Packages. Util is the package. Util Package, but in Util Package there's a lot of support. So I think we'll have to create many folders for what? Util Package. For lang package I had only one folder. Understood? So for Util Package what I'll do? I'll go on creating multiple folders. Util Package, the name of the folder is what? Collections. Yes. Again there is a huge history here. Java is giving you the support, but this support did not come to you overnight. It has happened over years of evolution. Means initially very less support was there. Then means versions. Java 1.0 some support, 1.1 support, 1.2 some support. There's some support. I'll be talking about that support later. But first I'm going to teach you what all things. See, today Java is in, see, first release of Java was 1.0, then 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8 is there. These many versions of Java is there. Every version changed. Okay, there's a huge support added to collections. So I am talking about this, whatever I am going to teach you now will be before 1.4. I am dividing like this now, because here very few changes. See, 3 major changes which happened in collection was, this was first one phase where some means initial introduction was, means few support was given in the first phase, very less support was given. I'll talk about those differences. In second phase, that is in 1.2 version especially, okay, in second phase a lot of changes happened. That is when the collection framework was created. Framework was created means what? That hierarchy of classes and all, a standard approach of working was done. Some problems again came out. More support was added in what? 1.5. we'll see. This is third phase. So I'll be teaching it in two phases, not three. These two I'll cover it off in one phase. This I'll cover it in another phase. Understood? These two I'll cover it in one phase. This I'll cover it in another phase. So don't bother much about those versions and all that. Okay, so versions and all that, very clearly I'll be carrying you. We have to move very smoothly here, but because this was the initial support. Okay, later on this support started. Okay, for initially this support was there, and later on this support was, some enhancements came up. We'll see what is that. So first I'll carry you before 1.4 or up to 1.4 what was the support. First I'll be teaching you up to 1.4 what was the support, and this is a major interview question. What is the difference between 1.4 and 1.5? Okay, what was added? This is a definite interview question, quite frequently asked. Okay, they'll keep on asking it, or you should know, or this is one way to take it is history of collections in Java. This you can take it, the heading is, you can take it like this: history of collections in Java. Okay, how they went on. See, giving support is not important, but see, even they have struggled to give support, and now you got the perfect support for working with group of data. You know, it's a simple thing what we require, but see, even they struggled so much, and finally you got the best solution. We'll see it. So that is why what I'll give the folder name is Util Packages. The version name I'll give 1.4. Are you following now? Util Package Collections 1.4. So it was old, new. I'll give, create one more folder 1.5. That we'll see next. Okay, so you should know the differences, how things started in Java, how it went on changing, and today what is the exact support we are getting now. So full history if you know, you'll become perfect. Okay, hardly it's a matter of 2 classes extra or 3 classes extra, but you'll become perfect, like how things were designed. Okay, so this is our workspace now. I've created a new workspace. Clear? So I'll open Eclipse here now. You know how to create a workspace? Yeah, so that's my workspace. So put all the I'll be putting all the examples of collections into this workspace. And change it to Java view. Yes, close all these unwanted things. Yes, so we'll create the first project now. New Java project 01 linked list examples. Linked list examples. See, all the examples related to linked list, I'll put it here. That's how you organize it. Tomorrow you want to refer to any data structure, now you can find it easily. Okay. Now next I'll work with array list. For that another project. Tree set, other project. Like that you organize. So anyway, just see this, and I'll increase the font size here. Window preferences. Just increase the font size to 11 so it becomes comfortable. Yeah, so I'll create a package now called as new package. Package name would be com.cluster. Always make it a habit of saving classes in packages. Okay, in company also it becomes very important, and stop using names like P1, P2. Okay, some good name use, because when you go to companies, package names are, see how important it's becoming now. Java.util, Java.sql, Java.io, how they organize. Similarly, you have to organize your classes. So anyway, when you go to companies, it becomes mandatory. So at least start following conventions. Com.cluster. In company when you code now, you will not say Java dot. Okay, you'll be telling com, means company dot. Supposing you are working in Infosys, com dot Infosys dot. Com dot Wipro dot. Com dot IBM. Like that, they follow some conventions. They have their own conventions. But start practicing it from now itself. Com.cluster, yes, finish. So in this package, I'll create the first example now, linked list. Demo 1, because we are going with many examples. Linked list demo 1. I need the main method. Yeah, so we can remove all this. Yes. So see, I decide to use a linked list structure now. So all I have to do in Java is what? Linked. Control space. So you can say import it. Automatically it imports. And when you import, see, this is some diamond is coming out here. The first time it's coming out to you. This is the new syntax. Okay, this is called as generics. So in 1.4, this was generics was not there. Generics was the support which was added in 1.5. So what you do, right now you delete it. Don't bother about that. That syntax, see, concept is same. Only syntax has been changed. That's why first get comfortable with what? Concept. Once you are comfortable with concept, syntax is secondary for us. So that's why I'm teaching you 1.4. Because if I straight away teach you 1.5, what happens? Concept also new, syntax also new. It will become very difficult for you. So that's why we will decouple. First I'll teach you concept, then I'll teach you the new syntax. Understood? So linked list, it is imported. I have to give a variable name. So I'll give the name as list. You can give any variable name is equal to new linked list. Finished. Done. See how easy it is in Java? More than that, nothing. Just you create the object, data engine is ready. And this data engine is encapsulating which structure? A linked list data structure. Understood? Yes, I'll start, if I want I can print some messages here. See, list dot size. Now size is an extra method which is present in what? Is a method which is present in what? Today what methods I'll be teaching you, they all come from what? Collection interface. Collection. Okay, means the common methods which will be available to all your data structures. So if you want, I'll open that and show you. Say this Java dot util dot collection. We are working with this interface. See, these are the list of, let's open the new one. Okay, we'll go with docs.oracle documentation. Yeah, so this is it. See, this is the new syntax which you will not understand. That is generics. So time being you exclude that, because till now when you are referring to this documents, you never came across this angular bracket. You have seen refer to the document till now. You saw which one? String buffer. Just I'll show you here, frames. If I go to java.lang package, you have seen some classes. Java.lang, you have seen the wrapper classes, boolean. You are not seeing any generic. Okay, here little it comes, but you can see the class name here. Okay, so very rarely you are seeing that diamond bracket or angular bracket. We call it as diamond bracket or angular bracket. Okay, if you go to runtime, I taught you runtime class now. Yeah, runtime class. See, hardly that syntax is not there. But when it comes to util package, that is collections, this is the first time you'll be seeing it. Already moved to Java X. Sorry. Yeah, java.util. When you move to the util package, yes, here you can see, if I open something called as linked list or something, anywhere you open, generally you'll start finding this syntax here. A linked list. See? So that syntax timing you avoid. Gradually I'll explain what is that syntax. But I'm going to the interface now. In the util package I'm going to what? These are classes, but I want which one now? The interface. Which is the interface we are dealing? Collection. So this collection. So study with the document like this. This document is, see, after giving library, Java will give what? Document for the library. You don't have to, after this, see, after you complete the language, means if you study those, what is that operator and all that, operator and control statements, data types, for that you got many books. But once you complete the Java language, then all authors end up in teaching what? Only built-in classes and packages. It's the same. So they also, while preparing their examples, they will be referring to what? These documents only. Any book you take, Bal Guru Swami, complete reference, what they do? These methods they are explaining to you now. Understood? So it's all simple now. So that library, for every library Java gives you, they'll give a document now. You should know how to use it. So this is for reference purpose. And you know the support of Eclipse also. Okay. So see, this is how the Java goes on to give you support for programming. Library is there. Document for library is also there. Then in this one, you got here list dot. Look at the editor support now. List dot. Tell you all the drop down. What brilliant support. Unimaginable support. Understood? In other languages you have to code everything. Here coding is ready, document is ready if you are not understanding anything. On top of that, editor is editor. Which one? Means powerful editors, not like Edit plus Notepad. Eclipse. These powerful editors give you such extensive support. That's why we end up using Eclipse. We can't code Java in what? Notepad, Edit plus. Initially we start off, but later on you need such powerful editors. So that is the support you are getting. Just go on seeing the support. Understood? So fine. So this is done now. So we are seeing all the methods in collection interface. So some of the common, see, these methods what you are seeing now are available for all the data structures, because all the data structures are implementing what? All the classes. They are implementing collection. You know this hierarchy, never forget this. This itself is the collection framework. Framework is nothing but what? A standard way to work with anything. A standard way to work with anything. But here, that anything is nothing but data structure. Understood? Collection is one standard way of doing something. Sorry, framework is a standard way of doing something. So that's it now. So this is the thing now. So we are studying the methods in, not all. I'll just start introducing. Okay. So not all the methods, but few methods I'll cover today. So yes, I'll be teaching you add, clear, contains. So these are all methods which come from collection interface. Say add. What does the add method do? Ensures that this collection contains the specified element, optional operation. So the reason, see, it gives you more information. The reason why you are joining course is very simple. Why? You are not understanding all this. Every book, everybody is teaching you the same thing, but the problem in you is you are not able to understand that. Understood? So that's the reason you are joining course. In course, it's nothing about learning libraries itself, and you don't have patience. Yes, because see, here we talk on experience. When I am teaching you library, we are not learning all the things in the library. That is what is experience now. What is exactly required, how much is required, that we have to learn. Because if you go on studying library, it's a vast library now. Okay, so that is why you join institutes and you should learn this properly. Understood? So see this. Fine. So this is done now. Add, like that, more methods are there which I'll be covering now. Slowly I start listing now. But which is the method I've shown you? First used size. I know that this method is present in what? That is experience now. Okay, we know which method is in what interface, what class. This is experience. So here coding becomes mandatory, not by hearting. Okay, see, the more you start using the library, the better you become with it. So generally you have an habit. What is your bad habit? You read a book and you think you know everything. That is wrong now. Okay, you should always code here. The more you code, the more you practice, what happens? You'll start understanding the library better. Understood? So till now in colleges you have done that. What is that? Okay, linked list. LL is equal to new linked list. LL dot add. Okay, it'll add the element. That is a wrong methodology. So we are only changing all you have learnt. We are changing the learning methodology. And seeing to that you are not by hearting anything and you are understanding everything. That's the approach what I am taking. Just okay. So this is it. Slowly you'll get used to it. So initial size of the array list is, I'll do one thing. Okay. List start size. Fine. Okay. Or I'll 1 second. List dot size. Fine. Then more things I'll type now. Just see, I'll call some methods. Sys out. Some more things. Okay, first I'll do one thing. I'll execute that. So what is the initial size of the linked list before adding elements? Just see the size. When there are no elements only, what will be the size? What will be the size? 0. That's it. Understood. Next, some more methods we'll see now. System.out.println. So like this, start coding. System.out.println. Yes. Is it empty or not? I want to check. Fine. What will you call? List dot. There's a method called as isEmpty. I'm calling this method now. Finished. In fact, it is empty only. So what the return type of isEmpty is what? Check. Boolean. I'm using what? First which method I used? isEmpty. Return type is Boolean. Size. What is the return type? Int. Everything given. Okay. So then, or even Eclipse is more pretty. See here, see. Just is. I'll delete it. I'll just show you again. Just dot control. Okay, 1 second. I'll delete it. See, dot control space isEmpty. What does it do? Same thing. It is showing you here. Whatever is in the document, it is the same thing showing you here. Okay. So you can use like this. isEmpty. Fine. We are using isEmpty now. Fine. So then next, we'll see the values, if there are any. There are no values, but just I'll print it for you. Contents of linked list before adding values. Plus, just I'll print the variable name list, nothing else. Okay, I'll just print the variable name list. So let's run the program now. Let's see what happens. So initial size is 0, isEmpty is true, and what are the values there? No values. Fine. Now we'll add the values. So first, what did I do? Comment always. Create a linked list. But did I implement it? I didn't implement it. Then next, after that, we'll add elements now. How will you add? Very simple. Adding elements to linked list, how do you do it? Adding elements are values in linked list. Okay. So then next, yes, list dot add. You want to add? No. See, so many methods are there to add. Some are extra methods. See, add index and all are coming in what? The sub interface. Add index is not a method present in what? Because index is something related with what? Array list, linked list, it is related to that. Okay, it is not related with what? Tree. Tree does not have list and all, no. So that is why if you see in the hierarchy, see this hierarchy properly now. Okay, all the common methods are kept in collection. All the common methods are kept in collection. Some extra methods will be put into what? List interface. So I'm not teaching you the extra methods, list, add, and see, that's in the next class we'll be studying all this. So the extra method, what we are, list start, now the add method now. List start, add, these many methods are there, but I'm picking the first one. List start, add, okay, and I'll add a value now, but we are hard coding here, remember, these values will come dynamically. List start, add, C. Next, you can add more values. So initially, when you created this object, what had happened was, one object was created now like this, and this was list, and it is having many methods here. Which are the methods we are using now? Size. So size is one of the methods. See, it's a big object. Okay, so here some methods are there. One of the method I used is size. Then one more method what I used is empty. Then one more method what I just printed list, SOP list. Which method is executing now? It didn't print the address. Means what? ToString has been overridden. So here ToString also has been overridden. Like this, they have plenty of methods. See, size is one method, return type of it is int. And one more method which I used is empty. Return type of this is boolean. Then ToString has been overridden. Return type of ToString is string. Fine, all that okay. So these methods we executed. Since there are nothing here, it printed what? Size is 0. Is empty is true. ToString, no, nothing it printed. You saw the output. Okay. If you want, you can see it again. These are three things what it's printing: 0, true, and see simply on angular, which on bracket is there, square bracket, but there are no values inside it. So you can see here, this is the one. Fine. Now there is one more method called as add, and it accepts an argument of type object. So which object I am sending now? I am sending an object now. It is a string object. So one more key thing to remember while working with Java collections is you cannot add primitives here. You cannot add primitive data. 10, 20 primitive you can't add. That is the reason they have provided what? Wrapper classes. So wrapper classes was introduced only for this reason. To what? If you want to add any values into collection, you have to convert the primitive to object. Means boxing you have to do and then add. Anyway, we'll see about that later. Today I am teaching you how to add string values. Integer values we'll see it in the next class. So I'll add now. So once you add, what happens? See, initially nothing was there. Now the linked list starts growing now. How it grows? I think I'll need more space here, so I'll start taking from here only. Understand that it's in the object only. Understood? So I'm just drawing it from here because I'll be adding more values. So next, C is there now. I added one value now. It is within the object. Just think like that. So it is added now. Next, it's a double linked list now. So fine. So one element got added. So then I can add more elements. See this. C, A, E, some values you add, man. B, D, any values like this you go and add. Yes, we added some values. So once I add the values, again the same three print statements which I was printing earlier, I'll print it now. Just see this. The same three print statements. What we had printed earlier. Same I print. What will this line do? This time it will display the contents. Display the contents of linked list. Finished. See here. Hardly I did anything. Values have started getting stored into linked list. Clear? So this is how the language goes on to give you the support. So what are the values I added? After C I added what? It starts growing. Means as the line goes on executing, as your program goes on executing, first it will add C, it starts growing now. Okay, it starts growing. See, it grows. Next element it adds. So again it grows. Next, what it is adding? A. Then it will add the next element. What it adds? It is growing like this. It starts growing now. Next, E. Then it will add E, B. D. F. Clear? C, A, E, B, D, E, F. These are the elements which have been added into the linked list now. Fine. So adding it is so easy. So fine. Next, if you want, okay, see now here SOP list, it did not print what? Address, because toString has been overridden. So what is this toString method? If you print, it will print all the values and display it to the user. That's simple. So fine. Now I want to check whether a particular element is there or not. Okay, one more thing, we'll see. Some more we'll see. See, after adding this, see now we'll check whether this can hold. When you're working with data structure, this becomes very important. Can this structure hold duplicates or not? Duplicate elements. This is very crucial now. Understood? See, sometimes you'll be picking the values from the database now. Some columns have duplicates. Some columns do not have duplicates. Yes or no? Like names. There's a column in database which is having names. And names can be what? Duplicates now. See this table now. There's an employee ID. You're having name. You can have phone. Now name, definitely two people can have same name now. But you want to get all the names now. So you're fetching it from secondary memory and going to store it in what now? Primary memory. And your data structure should support it. Some structure allow you duplicates. Some structure do not allow duplicates. Example, does tree structure allow you duplicate? No. And which one? Array structure allows duplicates. And it is again very clearly classified. You don't have to get confused. If you look at this framework, it is very neat and clean. The class which implements list will allow you duplicates. The class which implements set will not allow duplicates. As simple. Anything which ends with list will allow what? Duplicates. Okay, means see, that is the behavior, but how Java is making the user comfortable to use the library. That's the concept. But Java is giving you a good support to use the library now. So list allows duplicate, and it also allows what? Null values. Supposing I am filling all the email ID, phone numbers. Phone numbers can be null, no? Some people might have phone numbers, some people might not have. Some email IDs might be there, some email IDs not be there. So like this, when we start retrieving the data, so we need such kind of support now. Understood? So fine. See, I'll show you adding both. What? Can add duplicates and null values in linked list. For that, an example now. See, I'll add list not add. So I'll add, which is the value I already added? A, I'll add. Yes, it's a duplicate value. Already A is present now. Already A is present. But still, what will happen? See, list dot add. I'll add a value called as null. See, here you might think, what is the use of adding null? I know very well it is null. But these values come dynamically. Remember that. So that's the interview question they'll ask. Does a list allow you to store null values? Yes. So we are now talking from theory point of view. When it becomes practical, it will start understanding it very clearly. Okay. So when you're retrieving the values from the database and means from the columns and storing it now, you should know what are the different type of values which are present in your column now. Okay. If you don't want duplicates, see, phone number will be there. Okay. Then what you can do? Anyway, there will be no duplicates. So you have to choose now which structure you'll use. If there are no duplicates, if you want, you can go for linked list, or you want, you can go for array list, anything like that. Okay. But supposingly now, if I store it in tree set, the same phone numbers, it will be stored in what? Sorted order. Like that, you should know which structure to use, and that discussion we'll do it in the next class. Which structure to use when? That we'll be doing it in the next class. But just see the support now what you're getting. So yes, it can store what? Null values and runs here. Null value has been added. See, first there are no elements. Later on I added 6. Now I added 2 more extra. So now it is 8. And size is empty is what? False. Same 3 statements I printed. And now the values are these many values. Clear? Okay. So I want to check. Now next. So I want to check whether the element is present or not. check whether an element is present. List dot contains, I am checking whether it is present or not now, and I'll say E. If I want to check, see here it is 5 values, you can see it. Sometimes you'll have hundreds of values. In those 100 values you want to check whether a value is there or not. These are common things now when you're working with data structure now. These are very common things. Just you'll call what now? Contains. Implementation they are done, just use it. List dot contains of E. Next, yes, we'll print and see this. So it is what? Value E is present, true. I just modified better. Value E is present. Yes, true. If you want to check other value, I'll write. Boolean B2. I'm checking whether it contains an element called as R. Any value you want to check, value R is present, will be what now? False. See, the return type of contains is Boolean. You can check in the API. Contains. Where is contains? Where you are looking? Yeah, contains. What is the return type? Boolean. This one you can see. Understood? Sorry. Yeah, this particular thing contains. Returns true if this collection contains the specified element. So like that we are working. So refer to the which one? Document and code. Simply by adding you will never understand. This is how you have to use the library. Okay, value R is present. It is, this time it will be sorry, B2. False. Simple. And if I want to remove an element, list dot remove, fine. So after removing again, okay, see this. Anyway, when I remove it, it is deleted. It is not displaying because I have not printed anything here. So I'll print it now. So after removing, now you'll see list dot size and list. I'll print the two statements. These two statements I'll print. Initial size, okay. Size of linked list after deletion. Yes, size also I'll print, list also I'll print. This time what will not be there? B will not be there. Check. See, first these three output. If size was 0, okay, then it was true, means is empty was true, then no values. Then I added some values. So it was 8 values what I added. C, A, E, B, D, F, null and all that I added. So then it is empty is false. Then it is printing all the values. Then I checked contains. Value is present. Value R is present. Okay, true, false. Then I deleted. After deleting, what is the size? 7. And where is B here? So see here, earlier B was present after E, no? C was present after E, but now it is not present, it is gone. Understood? Because you deleted it. So that's the same thing now, what I did. So after I removed it, not only one, you can remove any number of elements, but this one, remove method now. So what did you do? You inserted, you deleted, like that you can work. We are learning how to do CRUD operation now. Inserting and deleting. Fine. Next, I don't want any element now. I don't want to destroy the array list. Sorry, I don't want to destroy the linked list. I just want to remove all the elements. So if you want to destroy the linked list, just say linked list is equal to null. List is equal to null will do what? It will dereference the object and all values are gone. But I don't want to dereference it. My intention is I want the list. Understood? But I want to remove all the elements. So that time what I will do? Okay. Delete all the elements in the linked list. So I'll just call one method called as list.clear. That's it. Finished. So after doing it, I'll just say sysout. Okay. Size of linked list after clearing. Less list dot size. And then I'll print the contents also. Contents of linked list after clearing. So after clearing, values are 0. Clear? So you saw how it is working now. So like this, you can code and get your output. See, few things what you have to observe here. It is allowing duplicates. It's allowing null values. And it is storing the elements in the same order as you are inserting. Ordering now, that's also very important. It is not, I first added which element? C. See, look at the output here, what you are seeing at the bottom. Okay, look at this line, C, A, E, B, D, F, this output you see, contents of linked list, after adding values, no? After adding values. So it will be what? Contents of linked list after adding values is CA, and look at the way I have added the values here. This is the same order I added now. It is storing it in the same order. Clear? So fine. So like this you can work with. So it is allowing you duplicates. It's allowing you null values. It is storing in the same order as you are inserting. That's the behavior of it. You just have to understand how it works. Okay. And see, one side you have to understand the data structure and its behavior, and the other side you have to understand how Java is giving you support for that behavior. It's already implemented. So that is the difference. Don't club now. Behavior of data structure is different. Support given by Java is different. Generally people what they'll do now, if they're not understanding linked list, array list, tree set, Java is difficult, they'll tell. How Java is difficult? Java is giving you support for that. You are not understood the data structure properly, that is why you are not understanding this library properly. Understood? So first you have to concentrate on the structures, then you will understand the library here. Generally people tell no, collections is difficult. Why it is difficult? Because they don't know the concept behind it. Java is giving you a library for that support. So these are the mistakes what people end up while learning Java. They leave the concept and they start by adding methods. Understood? And then they'll tell what? Java is difficult. You tell me which language is easier now? Other than Java, you tell me now which one is easy. If you are telling Java is difficult now, then C is easy. Do this in C now, let me see. Try to store some 10 string values in what? Linked list in C today. You will take one lifetime. But in Java, it's hardly a matter of 1 hour. You learned it and you're going to do it today. That flexibility I got in the language. Done? So fine. So this is how it works. See now. So this is about linked list. So these are some common methods which you can use in all structures now. That's what we are talking about. What framework means, one standard way. It's one standard approach given now. Same methods. I'm going to use it what now? Array list. Nothing I'm going to do. Just I'm going to change it to what? Array list. So what I'll do? I'll just copy this. One second. You code now. You know the same way you code now. So I'll create a new project. New Java project. 02 what? Array list examples. Done. Finish. So in this, create a new package now. What is that? com.cluster. Finish. Then in this you create a class called as array list demo 1. I'm giving the file name as 1. Fine. Little I'll code and show you, then I'll copy and paste. Okay, just see this. You want to work with array list now. So array list encapsulates what structure now? Array structure. Understood? So all you have to do is what? Array list. Control space imports. Don't have to worry only. Okay, what is the variable name? List. Sorry, that E. You delete that E. The list is equal to new array list. Done. Array list is ready now. Means you can store the values in what now? Array. See, there's a difference between primitive array and array list. But both are supporting which structure? Array structure only. Okay, but this is very supreme, powerful as compared to what? Your primitive array. Okay, you know your primitive array now. See, if I want to store a string of array of strings, how do you write? String yes is equal to, this is how you do it now, is equal to new, what you will tell. So this is there, but you have to specify the size here. Yes or no? This is an array of what now? String. But this is not powerful. It is fixed. It cannot grow. It cannot shrink. But this is very powerful. Understood? So I'll be showing you this. All this we'll be seeing now. Just work. Okay. And I'll be going more deeper into what is the difference between array list and array. Which one to use when. All those differences I'll teach you. But both are giving support for array structure only. Okay. So this we'll leave. You know how to work with this. We are concentrating more on what? Util now. So here. So just if you want, I'll just copy these 3 lines now. Means I want to print and check what is there now inside it. Initial size of array list. Then array list is empty before adding values. True, same. Contents of array list will be what? But look, the same methods. You are working with 2 structures now, but how many methods are you remembering? Same method. Okay. So whether it contains on, see this, just see. Yes, the same methods are working. Elements are 0, is empty is true, and there are no values. I'll add the values. How will I add? See this, the same values I'll add. Now it's getting added into what? But I didn't print. After adding, I didn't print. So it's been added. So what will I do? But I have to change some print statements. Initial size. Okay. Now I'll remove initial size of array list after adding elements. 1 second. I will take these prints from there. The print you don't matter, I'll modify and put it into the source code, means for you to refer. The print statements I'm not able to concentrate on it. Size of the link list after adding elements it is. Understood? After adding elements. So list dot size. List is empty after adding values? No, false. Contents of So but we are working with array list now. See, so I created an array list. Now what this, it is size is 0, is empty is true. Initially it will not print anything, but after I add the values, size will be whatever, then is empty is false, then the list will print all the values. But now the values have been stored into what? Array structure. It has been stored into array structure, and as you are adding the elements, it is growing. Initially there will be no array. I add one element, it grows. Next element I add, it grows. Next element I add, it grows. So it is expanding. Understood? So this is an expandable array, but your primitive array is a fixed array. Understood? 5 means only 5. You cannot add an extra element. If you add an extra element, what happens? Array index, if you use a wrong index, array index out of bound exception and all you start getting. So they are the problems. But actually the problem is, now you understand, when you are retrieving names from the database, how will you know how many names have come? Think practically now. So you will be forced to use what now? Array list. Phone numbers are coming. How many phone numbers are coming? How will you justify? Correct. So that is when you need an expandable array. So that's when I will go for array list. So this is how it happens. Then next, if you want, you can add, say I can add duplicates also. This will also allow what? And it is storing in the same order as inserted. So the same features almost all. But behind the scene it is using what? Array structure. It allows duplicates. It is storing the elements in the same order as inserted. Okay, it is allowing null values. Understood? Almost all same. So all things related which have one behavior are implementing what now? Now you come to diagram. All things which are having a similar behavior are implementing list. Similar. But again, they have their own data structures. One on data structure, some data structures are similar. Understood? But huge difference is there in other things. We'll be seeing the difference between array list, linked list, array, linked list and all that. Okay, but now array list is using array structure, linked list is using linked list structure. Finished. So yes, now it will allow duplicates. Now you can print. Now this time the values will be what? Yeah, this time the values are 8, is empty is false, and it has added null value, and it is storing in the same order as inserted. Then next, some more things you can add. I'll delete. Okay, check whether an element is present or not now. Understood? So value is present. So just what I'll do, display the contents. But you can see the common methods now. That is a brilliant. This is what is framework. You are working in a standard way now. You are right now understanding why you use an interface. See, now they can't do any implementation now. Why are they using an interface now? If it is a class, what will happen? They have to do concrete implementation. But if it is an interface, what will happen? They have to decouple. See, sometimes you want to do concrete implementations. Sometimes you do not want to do implementation. In this scenario, they did not want to do any implementation. That's why they chose the interface. And these are classes which are implementing those interfaces. Why did they do this? So that we can have a standard in working with all the structures. So remember, two of the most important points of interface I am covering now. Interfaces actually help you to decouple declaration and implementation. And one more point what we are discussing is interfaces always set standards. And one more point we had discussed, interfaces always state what they do but not how it is done. So collection, it is saying add method is there, contains it's telling, but how it is done depends on what? The implementing class. So contains logic will vary in array list. Contains means how they are going to check whether the value is contained in that data structure or not will change from what? One structure to another structure. Implementation is changed. So interfaces always state what they do but not how it is done, because it will differ from one class to another class. So this is what you are first seeing, what? The implementation of an interface, or this is the first time you are coming across the data type called as a interface. So more you see, more you will understand. So lot of concepts have to be covered here, from starting from what? Data type, means why did they use interface here, why did they use class here, then next the behind the scene concept, then the library. Too many things are there to discuss and work. So practice. Understood? So this all can be understood only by coding. Practice. Understood? So this contains. Next, I want to remove. Fine, remove it. How will you remove? Same methods here. Remove an element from what? Array list. Yes. So the size will reduce now. Is deleted. Which element is deleted? B. It is not there. Size is what? 7. Fine. Then next, I want to clear. Fine. So in the array, the values are gone now. The no values. The only difference you would find here is, earlier we are working with a linked list. This time we have started working with what? Array list. Means let this remain. Now this array object is of type what? Array list. So first no elements will be there. Just remove it. First no elements will be there. Take this part now. Okay. So first I added what? C. Then I added what? A. Fine. It grows. Then I added E. Then I added B. Then I added D. Then I added F. Then I added a duplicate element A. Then I added a null value. Fine. This is array. So I removed one. This was deleted. I cleared. Everything was gone. Simple. So you have got on standard approach now. These are common operations. What you do now? What? Adding an element in a data structure, removing an element from a data structure, checking whether an element is there or not, clearing all the elements in a data structure. So these are common things which are required for what? All data structure. So that's why they kept these common methods in that interface. I'm highlighting the interface. Keep on observing it. Understood? So this is how Java supports encapsulation. So to support OOPS, Java is giving you 4 data types. So again we are coming back to OOPS now. Yes or no? Java is giving support for what? OOPS. Okay. So once you understood this, now you know the hierarchy. List. See what is the powerful support Java gives. List is the super interface of what? These two classes. It's implementing now. Which one? Linked list. And array list is implementing what? List. See what is the benefit of this framework? Okay. See first, till now I was creating object like this. Array list is equal to new array list and I was adding the values. Understood? A linked list list is equal to new linked list and I was adding the values. New linked list, sorry. Clear now? But instead of this, if I do this, a list is equal to new array list. This is dynamic polymorphism. You add your values. Say list dot add. You are adding C, A, E. You can remove a list dot remove. You can check a list dot contains. All same methods. So right now superclass variable is referring to what? Subclass object. That itself is called as dynamic polymorphism. Tomorrow you don't like array list. What will you do? Change your man over. You change your structure itself. Imagine. These are common methods which can work with what? That structure also. What brilliance. You can change your structure in fraction of a second like this in Java. Do it and see. You can see what flexibility they are giving you to work. Terrific support. Understood? So we'll see what excellent support they're going to give you to work with data structures. We'll be seeing it. But this is where the dynamic polymorphism comes into picture. Understood? Superclass means why do you do dynamic polymorphism? See, this is decoupling now. I told you, see, we had one question. When will you create the subclass object and refer it with superclass variable? When you need dynamic polymorphism support. All that practical implementation we are seeing now. Because if you create the subclass object and refer it with superclass variable, the advantage is you can change your implementations tomorrow. Yes. And if you tightly couple like this, what will happen? You are going to work only with array list now. So anyway, I'm not telling always this is good, always this is good. You decide whether you want to tightly couple and use only array list, or you are going to change it tomorrow and you want to keep it decoupled. Such excellent support it's giving you. That is why they are going with common methods. If the common methods were not there, what would have happened? Compilation error now. Now what support you see now? Understanding this excellent support. So now you start understanding the benefit of Java data types. Which one? Class, subclass, abstract class, interface. So why they have given you 4 data types to implement OOPS? Now slowly you will start getting the idea about it. Yes or no? Till now you know what is class. Yes, no? What is class? Class is class. What is subclass? Subclass is subclass. Correct? Now you see. Okay, so we'll continue now. So this is about 2 structures. Now I want to store the values in what? Tree structure. Fine. Tree set TS is equal to new tree set. Finished. All the elements are getting added into what? Tree structure. But remember, in tree structure, the elements will be sorted. It will not be in the same order as inserted. Understood? So that's all. So developer here has to understand only the behavior of the structure. He is not interested in implementing it. So just I'll code and show you that also. Are you understanding now? This one? Means I've just today I have highlighted what is framework, collections framework. That is my main point today. One side I am introducing you data structure, other side I am highlighting what? Framework. What is framework? Means on standard way, no. Earlier this framework was not there. You know, up to the first phase, framework was not there. Later on in 1.2, they added the framework. I'll go on to explain you that later. Don't worry. What happened? How the revolution happened. Okay, fine. Next, this is array list done. Then I'll go with what? Tree set examples. New Java project 03 tree set examples. Sorry. You see this, you want a tree structure, finished. Tree set, finished. The structure is ready. One control space coding is done here. Just control space means I am talking about Eclipse now. Tree set is equal to done. Now what you have to do? Again same, you check what? Size, capacity and all will be what? If you want check. So these are common methods which are available to what? Tree set also. Because tree set is also implementing what? Sorry, extending. Tree set, see the hierarchy. Tree set is, where is tree set? Here. Tree set is implementing this interface. This is extending this interface. This is extending this interface. But finally it is extending what? Collection interface. Fine, not a problem. So you can use those common methods you can use now. Okay, so fine. And here you have to use set. Okay, I executed that program. Tree set I'll execute. Yes, elements are 0, is empty, true. It does not contain anything. Fine. So then we'll add the values. How to add the values, you know? Values in tree set. So now it will be stored in what structure? Tree structure. Just I'm in a hurry, so just understand output, you don't bother. Okay, you got the concept now. So size of tree set means if I make any mistakes in printing, I'll modify and put it while putting it. So size of tree set after adding elements, tree set is empty. After adding values, contents of tree set after adding values. See now, I'm adding it in tree structure. Fine. Look what happens. It is stored in alphabetical order, sorted order, and it takes natural ordering. I'll explain what is natural ordering. Default will be storing it in alphabetical order, in the natural order. Understood? So anyway, it's stored means you are adding the elements in this style, but it's stored here like this. Fine. I'll try to add a duplicate. Let's see. If I add a duplicate, what happens? We'll comment later. Set dot add. I'll add the value a. So any value you want, or duplicate value. Will I get an error? No compilation error. Do I get runtime error? No runtime error. It is executing. But what happens? It won't add. It is not adding. Okay, it skips because it found the element inside the structure. How will it find? They have done the implementation. I'll explain you what it is, how it works. But already they have implemented it. So tree structure should not allow you duplicates, and it is allowing you in storing in sorted order. So where will you use tree structure? Example, in the database, one table is there. Example, see this. I don't want duplicates. My requirement is this now. I don't want duplicates and I want everything in sorted order. Understood? So in database, there is employee ID, his name is there, and his phone number might be there, and he might be coming from one city. Example. Okay, I'm just taking one example here. 101, 102, 103. His name is A, B, C is having a phone number. Okay, but two come from Bangalore. He comes from Mysore. Like this, more you can have. Bangalore. So I want to get all the cities where my employees are coming from. So I'll select it. Means how will you do? Select city column you will do. And it is coming from secondary memory into primary memory. In primary memory you have to store now. So which structure will you use? If you put it into array list, duplicates. Not only 3, you can take more employees. Now again one more will be in Mysore. Again one more will be in Mumbai. Again one more in Mumbai. But I don't want to display all these duplicates. And I want it in sorted order. That's my requirement now. Just collect, fill it into what? Tree structure now over. You're not even bothered about anything. Understood? So duplicates are automatically eliminated. In the query you got duplicates. But when you're storing it into this structure, that structure implementation has been done. It will only eliminate and store it in sorted order. And if you try to add a duplicate, it skips. That is what is the meaning of add method. Now look at the API. What does the add method do? Okay, you have to understand this. Ensure that this collection contains the specified element. First it ensures whether it is containing or not. Return type of that is boolean. Okay, if it adds, return type is true. If it skips, return type will be false. You can accept the return type and check here. Here I have just said add. Accept the return type. First time it will be what? Means here I could have said boolean b1 is equal to boolean b2. I could have done it. Okay, check. Here it will be true. But here it will be false. Boolean b1 will be true. Add method return type is what? Boolean. This time it will be false. You do all this already now. So this is a very important question. What does add method do? First it checks if the element is there or not. If it is there, for some structures it will add, but for some structures it will not add. So when it gives you true, when it gives you false, that you should know. For array list it will never give false. For linked list it will never give. But for tree set, hash set, in both of them duplicates are not allowed. Tree set and hash set. Done. And similarly you can work with what? Clear, remove. I'll just show you remove method now. Okay, sorry. Duplicate I finished. Now, okay, after means cannot. In fact, I'll comment it now. Cannot add duplicate values. It looks like you can add, compilation error no, runtime no, but finally if you see it is not stored only. Understood? So next I'll try to add null value. Let's see what happens. Comment I'll do it later. What is that? Set dot add null. What happens? Compiles. Okay, but during runtime you'll get an exception. Null pointer exception. Actually this is a, see, it went on to execute these print statements on the top. It executed these three statements on the top. It executed. Now when it comes to execute here the exception occurs. That is why it's skipping these 3 lines. It's not printing this. Program terminates. Exception now, you have to handle it. Okay, we'll see exception handling later, but you cannot add a null value. And while printing, don't get the print. What is happening? First it's printing, means first exception is printed. That's display problem. But actually first only the 3 lines are getting printed, then the exception is occurring. Okay, fine. That's a display problem. Don't worry. Okay, then next set dot add. This is done. And then you can again, now what you can do? You cannot add. So you cannot add. That's what is the comment now you have to do. Cannot add null values in tree set. Cannot add duplicate in tree set. So you cannot add. Why do you want it? Just comment it off then. Just for your understanding, I have done it. Done. Same next. Clear, you will do it. Clear, remove also. You can check. Say set dot remove. I'll remove an element. Which element? Same element I'll remove. B. So it will not be there now. First it was there. See first, okay, I think I have printed only once. After adding I have to print one more time. First I'll print it here. See first A, B, C, D, F is there. After deleting, B is gone. Common method. Okay, so now last, has set. New Java project 04. So hash set uses hashing technique to store values. I'll explain what is hashing technique. You don't have to worry about all that now. All these data structures I'll be explaining you. Okay, and in this structure, duplicates are not allowed. Understood? And it stores in a random order. Ordering is not guaranteed only. It will not allow duplicates. And on top of that, you add C, A, E, B, something like that. It will store it in some order, whatever it wants. So that is how hashing technique works. Just see it. Okay. So hash set. Hash set is equal to new hash set. That's it. So it will be storing values using hashing technique. That's one more way you can store it in primary memory. Just you can print the same things. Size and all will be what? Size and all will be same thing. Is empty, true. Same story continues. No values. I'll add the values. After adding, I'll print. Okay, after adding, I'll print. Look at the order now. Okay, I have to change the print statements now. Size. After adding elements. As set is empty. After adding values. Contents. After adding values. Check what happens. 6 is empty is false. What is the order I have added? Look at the order. Is not guaranteeing the order. Okay, so your requirement is this. I want all the 4 numbers. Okay, sorry, I want all the city. Okay, but no duplicates. But order is not important for me. You can use has set. Cities I want, but not in sorted order. Order is not important, but I don't want duplicates. So like this, depending on your requirement, you start choosing the structure. You want duplicates, no duplicates. Okay, like that kind of. We'll see there are a lot of things to be discussed. Just I introduced all these data structures to you, and then next I'll try to add what? Duplicate. Let's see. Here also it will not allow you. Which is the duplicate value I'm adding? B, no? What is the duplicate value? A, I think. Let's see what happens. Any duplicate you add. After adding, means I have to print it before also. So if you use Alt and down arrow key, Alt and select your line, and if you use Alt and down arrow key, it will move down. Alt and up arrow key, that shortcut of Eclipse, it will move up. So like this you can do. So after it will move, it will not. On this one, contents of array are set after adding duplicates. It will not be there, see there. Again I added what? A. But 2 times it's printing. One before. See, first I have printed contents of as set after adding values. I have added again A, then I am printing. But second time you can see in the second output A is not, means only one A is, it skips. So your add will be false. But order is not guaranteed. Understood? So if you want, you can remove now, it will be deleted. And if you want, you can clear also. If you want, you can check whether it contains. All that you can do, not a problem. Understood? So this is how the has set works. But what about null values now? That's the last important thing now. So cannot add here also what? Set dot add. Will it allow null? Yes or no? Think. You might get a null value. Understood? And I am trying to add it in set. What happens? This I will comment. Set allows null value. So all will allow null value. Only which is not allowing? Tree. We'll see why. Reasons I'll give you. Okay. But again you have to think from a broader view, because here I am hard coding. Values will come dynamically. So if you are expecting a null value and you don't want duplicates, order is not important for you, go for has set. You don't want null, you don't want duplicates, you want in sorted order, go for tree structure. Like that you go on to decide. So in array list, linked list and all, in what order you store? Check this out now, the diagram. In array list, linked list, array list is implementing what? Linked list is implementing what? They are implementing list. So they allow duplicates. So what class implements list? It's very simple now. Allows duplicates. Suffix will only highlight. Set will not allow duplicates. That's the major difference. Okay. Next, has set is just implementing set. But look, tree set is implementing sorted set. Understood? So any class which implements sorted set is going to sort. Neatly organized framework. You will not have confusion only. So neatly to work with all the structures, they give a standard format. Only you have to understand the hierarchy of classes here. Understood? So this itself is called as collections framework. Understood? So more we are going to see, and more I will discuss. And this is just an introduction to support for data structures from Java language. It's just an introduction. Okay. End of the day, this is what you have to understand. From programming point of view, you have to understand only this much. What? Whether this allows duplicates, not allows duplicates, what is the order it stores, okay, and whether it's going to sort or not. These are the few things. Okay. End of the day, you have to understand this much. But there are a lot of interview questions which come out in collections, which we have to cover, and you have to understand it better, so that when you start getting multiple values, many values, you should know how to handle it. So writing logics in application is the easiest. Handling data is the toughest. And we have been learning this from past, the beginning of Java language. Okay, and still it continues. So I think this would be the last. And once we complete this, we can write any logics. Any logic, because it's all related to what now? Application. So in Java, we focus only on what? Not on the silly things. We focus only on the domain logic. Domain means any logic related to a banking application, focus on that. Any logic related to insurance application, focus on that. That is called as domain. So that is the flexibility Java gives you because of libraries. All these small things now, like writing logic for strings, writing logic for input output, writing logic for multi-threading, writing logic for anything, it comes from the library itself. Collections. Okay, so that's how it has been done. So some more things to understand. See this. This is one more diagram. I showed you this diagram. Yes. Okay. So let's list some key points here. So till now, what did you understand now? See the points. Neatly jotted down. Every point you should understand now. Collections is what? Group of similar data. Don't by heart. Clearly understand. Collections is a group of similar data. Collections allows to add, retrieve, update or delete data in primary memory. I didn't show you all, but I'll be showing you. But it is dealing with what? Primary memory. Okay. Using different data structures. Java provides collection framework to work with what? Collections. Now got the point? It's giving you the collection framework to work with collections. Means on standard. Now see here. The collection framework was added in Java 1.2 version. Earlier it was not there, it was added in 1.2. Means they are having their own methods. Their own methods and all. I'll explain that later. Okay. But a framework, what is a framework? A framework is a standard way of providing services very easily. Very generally I am putting it. You'll have many frameworks. Okay. This is one of the framework, first framework what you are seeing. Okay. The collection framework has a set of what? Standard interfaces to work with different data structures in a standard way. Simple. Understood? All the classes in the collection framework implement this standard interfaces and hence provide a standard way to work with different data structures. Understood? Then all the classes in the collection framework are data engines encapsulating what? Data structures and have heavy efficiency, high efficiency. You prepare your linked list, only God should use it. Understood? So, but here you can see they are having very high efficiency and accuracy. So we are relieved of all this. Understood? Then next, in Java, developer need not worry about preparing these data engines. Instead, he can directly use the ready implementations, that is classes provided in Java.Util Package. Understood? The next point, for example, linked list encapsulates what structure? Linked list data structure. Class tree set encapsulates tree data structure. Class array list encapsulates array data structure, etc. Many are there, we are going to see. Okay, there are other classes, but these are not collections. They support collections, which I'll be covering later. Still, I have not introduced this. Collection is an interface. Collections is a class. This is one more supporting. We'll be seeing it later. Till now, today I introduced what? Collection interface. There's one more. If you add S, it is also there, but it's a class. Understood? So you can see in the hierarchy here. Collection is what? Interface. There's one class called as what? Collections. That is an interface. This is a class. Understood? So we'll be seeing it. They'll ask you differences. Understood? Enumeration, iterator, list iterate. These are interfaces. Leave them right now. Now history. History of Java collections. This is your history you have to understand. See, actually these earlier for supporting data structures now, there are only 5 classes. Java also was not giving major support. It was not giving you support for what? Linked list, queue, understood, and tree earlier in 1.1 version. These are all classes. Only 5 were there. Only 2 support was there. Vector class is supporting what? Array structure. First vector class. Its name is vector, but it is actually supporting which structure? Array structure. We'll discuss that later. Understood? Stack supports stack structure. These 3 are different. We'll see. They are supporting key value pair. So only you had built-in support for what? 2 structures. When? In 1.0 actually. This was there in 1.0. But all books will tell you up to 1.2, up to 1.2. Up to 1.2. Understood? So that's why I just put a flower bracket. But actually they are introduced in 1.0. Okay. So developer was struggling. Every structure he wanted, you were preparing now. And Java realized developers are having problems. So that is when in 1.2 they first created a framework. Then they went on implementing the classes in 1.2. So look at 1.2, what happened? Collection framework was introduced. List, set and map interfaces and subsequent implementing classes like linked list, array list, tree set, hash set were released. So in 1.4 you started getting excellent support. 1.3, 1.4 hardly any changes, means there are no light changes were there, but they are not highlighted. Very small changes are there, but they are not highlighted. Leave that. Major change happened in what? 1.5. A new Java syntax was introduced. To support collections only, now what was introduced? A new Java syntax. Syntax only they changed. What are the syntax change? 3 syntax changes. Enhanced for loop. Enhanced for loop was done for this purpose only. We'll see it. Why they introduced? Auto boxing was introduced for what? See, earlier if you want to add a value in linked list LL is equal to, LL dot add. If I want to add a 10 value, you are telling new integer of 10. Like this you have to write lengthy code. You are having problem now. You don't want to code like this now. You want to code and finish what? Fast. So that's why they introduced. Means earlier you were doing boxing explicitly. Now only this much. Simplified. Everything is given for your own benefit. So the more you understand, more benefited you are. That you don't forget. It takes time, but you're benefited in the last. Understood? So fine. So here, new Java syntax, that is auto boxing, generics. I was talking that diamond. So that was introduced only for what? These all 3 things were introduced only for supporting what? Collections. Apart from that, some other changes are there in 1.5. That is why generally these are very frequently asked questions. What is the difference between 1.4 and 1.5? 1.4 or 1.5? Major changes happen. Then 1.6, some more interfaces were added. Understood? And in 1.7, a small change in that diamond syntax happened. We'll see it as I go on teaching you, because till now you don't know generics. This is the history now. Okay. So this is how the history of collections has happened. So we are yet to see more things. And if you want, which class was introduced when? You don't have to by heart. Nothing by hearting. Okay, you want to remember all this? No, nothing. Very simple. You go to collections framework. Yes, you want when was array list added? No. Click on array list. You know this one now. Come down. Somewhere you'll see since. You can see the versions there. 1.2. Very clear it is. Document gives you full support. You don't have to struggle and by heart anything here. 1.2. So I'm just showing you how to use the library and refer to documents, and at the same time how the editor is giving you support for programming now. This is what as a developer you have to understand here. Okay, vector. I'll click on vector if you want. See here. Which class? Vector class. Vector class. Yes, when was it introduced? Direct known subclasses is stack. Leave that. But it was introduced in 1.0. Clear? Neat. Don't by heart. Be relaxed, more you can learn here. Understood? So don't make Java as a burden, because you make it as a burden. Okay, in fact Java is one of the easiest language because of libraries like this. Understood? Which language can be better than this, you tell now, for working with data structures? In fact, in one day you completed what? 4 structures. Unimaginable, no? That easy it is. So like this is the one more thing now what you have to understand, but I'll be explaining you point to point how it has happened, phase by phase, and you'll be understanding all things neatly and clearly. Done? And see here I have highlighted before to Java 1.2. I have written some document for that. There are 5 legacy classes. They are called, these 5 classes are called as what? Legacy, old. Okay, legacy classes, and one legacy interface which are as follows. Enumeration. Okay. So these are the 5 classes and this is one interface. We'll discuss that also, I'll be teaching you, don't worry. These 5 legacy classes are used to store what? Store and, same thing. Store and manipulate group of objects, same, nothing else. Vector stack are used to store what? Multiple objects. Dictionary, hash table and properties are used to store key value pair. And among that, dictionary is obsolete. Means it's removed now. Completely gone. Okay, it's not there, don't use it. We'll see why they did that. Now what is the problem? This is one of your interview question. What are the problems with old legacy classes? Yes. So all legacy classes are synchronized by default. Synchronized means what? They'll allow, if multiple threads try to access this object, they'll allow only one thread. And it brings down the performance. See, imagine now, you have stored some data in one, which one? Vector. Means vector is encapsulating what? Array structure. Fine. But one thread enters now. Now other thread has to wait to get the value now. So it brings down the performance. So that is the reason, that is one of the major reason a change was going to happen. Okay. So that is one, anyway, just they are synchronized. And all these classes support only few structures. This is one thing you have to, only 2 structures that they are supporting. One is array structure, means vector class was supporting array structure. Stack class was supporting stack structure. Now tree structure, hashing technique, okay, linked list, no support only. Queue, no support only. So that's the reason 1.2 framework was designed. Some key points. These points you write it down. Later on we'll be discussing this. Some key, because I have not discussed this. Some key points to remember while working with collections. Collections cannot store primitive data. Remember that first thing, print it in your mind. Okay, you cannot store primitive data. Never ever try to add, but it looks like you're adding. See here I'll add. Because we are using, I can add it. Here I'll add, see here. So I'll do it in linked list. Huh? List dot add. I can do it. Then valid. It looks like it's allowing you now, but we are using 1.6 compiler. So never forget that. Understood? So because of boxing it is allowing you. If you try to do it in 1.4 you will get compilation error. Because you know the add method tells what? What is add method telling? What is add method telling? Add an object. Understood? So you cannot add primitives. But here it allows you. And yes, if you see it, these are more things to discuss. Okay, we'll be doing it tomorrow. It allows dissimilar data also. One is string, one is int. Now, just see and come. Tomorrow we're going to discuss more on that. So I'm executing the same program. I just added what? 10 is there. All more things we'll be seeing tomorrow. Okay. So just see and come. Okay, anyway, we'll come back to the document. So they cannot store primitive data. Fine. Now all collections which are implementing collections interface, collection interface can be converted to an array. Means if there are values in linked list, no, I don't want linked list, I want to put it into an array now. So you can do it. There's one method to array. Where is this method? If it is available to alt structures, it will be available where? Collection interface. So this method and all I'll be covering. Okay, so to array is a method which converts what? Means it will retrieve the data and put it into one array for you. We're seeing it. Understood? Now what is the advantage of doing it? See, to pass an argument to some legacy method, there's an old method before to 1.4. Okay, so for that you have to pass what now? Collection of values. So in 1.4, before to 1.4, you didn't add, sorry, before to 1, not 1.4, 1.2, I'm sorry. See, assuming that there's one method in 1.0, 1.0 there's one class. See, 1.1, 1.2, this story is there. Array list and all was added in which one? 1.2. Fine. So assuming that there's one class called as hello, you have written, you only have written, and there's one method called as m1, but it will take an array of what? String. Some means there are built-in classes like this. Here I am writing. There are so many built-in classes which will accept what? Only primitive arrays. So that is when you will have to convert what? Any collection to an array now, and then send it as an argument. So that is one of the reasons you'll be doing it. And sometimes there are some operations which are considered to be faster in array structure. So for these two reasons you'll be converting any collections to array. You'll be doing it. So just understand these key points. Okay, and we'll be discussing more on this. So that important collections is work. Okay. So I think yeah, we are done for the day today. That's it.